Hi everyone, you are welcome back to another interesting question. We are asked to calculate the length of the red line, that is this here. Assume its length to be h. We have the length of this line segment to be 2.5 kilometers. That of this is 9.1 kilometers. This segment is 0.9 and this is also 0.9. Here they said the three cycles are identical. That is, this cycle, this and this are congruent. Lastly, here we have that the point with the thick black color is a point of contact, while the point with the white and black color is a point of intersection. That is, this is a point of intersection of this line, this and this, while this point, this and this are point of contact. So how can we solve this? How can we calculate the length of this straight line? The first thing we are going to do, we label this point A, this B, this C, here D, let this be E, this F, and this G. Let's come back to this. The thick black point is a point of contact. Literally means that this line AB, this line AE, this line AG, and this line CF are tangents to these cycles at this point, this, and this. That is why the points were referred to as point of contact. Now let's look at these three cycles. Recall, they are identical. That is, if you draw out their radii, let's say to this point of contact, this and this, they'll have equal length. Assume their lengths to be r each. We know this point, this and this are centers of the cycle. We label the centers. Say this is P, this Q, and this R. Now don't forget, this line is a tangent to this cycle at this point. This is also a tangent to this cycle at this point. The same is for this line. It is also a tangent at this point. From the cycle theory, there is a rule that the tangent of a cycle is perpendicular to its radius through point of contact. That is, this tangent is perpendicular to this radius at this point. This is also perpendicular to this radius, and this is also perpendicular to this. So therefore, this angle, this and this are right angles. Now we come here, draw a line that connects this point A and this P. Assume its length to be x. Now look at this triangle ABP. It is a right angle triangle. We have the length of this side to be 2.5 kilometers. That of this side is r, and this is x. We use the Pythagorean theorem, which states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. So by Pythagoras, x squared equal to 2.5 squared plus r squared. 2.5 squared is 6.25. So x squared equal to 6.25 plus r squared. We keep this equation aside. Now come here also, draw a line that connects this point A and this Q. That's line AQ. Assume its length to be y. Now look at this triangle. It is also a right angle triangle. If you use the Pythagorean theorem on it, this is the hypotenuse. So the square of its length y will be equal to the sum of the squares of this h and this r. So y squared equal to h squared plus r squared. We also keep the equation next to the earlier one. Come here also, draw a line from point A to this point R. Assume its length to be z. We also look at this triangle AGR. It is a right angle triangle. So therefore, we can use the Pythagorean theorem. This is the hypotenuse. So by Pythagoras, the square of its length z must be equal to the sum of the squares of this 9.1 and this r. So z squared equal to 9.1 squared plus r squared. 9.1 squared is 82.81. So z squared equal to 82.81 plus r squared. Now if you come here, this line CF is also a tangent to the three circles at this point, this and this. Now we draw the radii of the circles from the point of contact to the centers. That is this point P, this Q, and this R. We know their length each are going to be R. Recall the rule we used earlier, that the tangent of a circle is perpendicular to its radius through point of contact. So this tangent is perpendicular to this radius, this and this. So this angle, this and this are. The next thing we are going to do is to come here, draw a line that connects this point P and this Q. Now look at this quadrilateral CDPQ. This side PC and this DQ are equal in length. They both are perpendicular to this line CD. That is, they are parallel. The only type of quadrilateral that has two opposite, equal and parallel sides is a parallelogram. So this is a parallelogram. Another property of a parallelogram is that opposite angles are congruent. That is, this angle and this are equal. So this is right, and this are also equal. So this is also right. Now the right angles prove that the parallelogram is a rectangle. We know opposite sides are equal. So this side is equal with this. Therefore, the length is 0.9 kilometers. If we also come here, draw a line QR, look at this quadrilateral. Following the same procedure we did with this, the length of this side is also 0.9, and this angle and this are right angle. I believe there is no need to prove that this line PR is a straight line. But if you doubt, just look at this quadrilateral. It is a rectangle. Now we focus on this triangle APR. We see this line AQ is a CV and it bisects this side. Therefore, it is a median of the triangle. Now since it is a median, we apply the Apollonius theorem, which states that the sum of the squares of any two sides of a triangle equals twice the sum of the squares of half the third side and the length of the median bisecting the third side. So by this rule here, the sum of the squares of this x and this c must be equal to 2 multiplied by the sum of the squares of half the length of this side, which is 0.9, and the square of this y. So x squared plus z squared equal to 2 times 0.9 squared plus y squared. 0.9 squared is 0.1. 2 times 0.81 plus y squared is 1.62 plus 2y squared. We come back to these values. X squared equal to 6.25 plus r squared. Y squared equal to h squared plus r squared. And z squared equal to 82.81 plus r squared. Substitute them here. So 6.25 plus r squared plus 82.81 plus r squared equal to 1.62 plus 2 into bracket h squared plus r squared. 6.25 plus 82.81 is 89.06. R squared plus r squared is 2r squared. Here 2 into bracket h squared plus r squared is 2h squared plus 2r squared. This 2r squared will eliminate this 2r squared. Take 1.62 to the left. 89.06 minus 1.62 is 87.44. Divide both sides of the equation by 2. Here 2 cancels 2. While here 87.44 divided by 2 is 43.72. Now take the square root of both sides of the equation. Here square root of h squared is h, while here square root of 43.72 is 6.6121. So h equal to 6.6121. That is, the length of this straight line which we are asked to calculate is 6.6121 kilometers. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.